zone, and then you learn what can happen and see if we can optimize that one. And if you can see on the upper right, there's a second increment and a second curve where they actually did that sand selective injection and got another increase in production. So that's without CapEx. On the bottom, we have another case study with an operator who did have capital to spend. They had drilled 15 wells over the past 5 or 6 years, and you can see the production has a few hiccups, a few bumps, but they really cannot arrest the decline. So 4Oil comes in and they optimize the water flood and propose deploying capital. They picked 8 sweet spots ultimately. Client and 4Oil high-graded those to 4. They drilled those 4 wells, got a 60% increase in production. That production also has sustained itself. We did some diligence on that with some publicly available data, and that upper curve has sustained itself over time. So it's a really interesting and unique way, and it's very different. It's very challenging to the reservoir engineers of the world who grew up with Eclipse, which is a fantastic tool, but this is a very different thought process, an analytical process to optimize reserves. And it works. So, what's the future of digital technology in oil and gas? Who knows? Who knows? Bob is right. We run a big risk of trying to think that we can do things overnight. I mean, if I hear another guy speak about how great Uber is and how they revolutionize everything, and say, well, why doesn't the oil and gas industry innovate like that? I think I'm going to puke, but there I just said it, right? We are a very physical industry. Even though we use technology, we use digital, we use logging while drilling tools you were talking about, seismic, 3D, 4D, all this sort of thing, but you still ultimately have to move in, rig up, spud the well, turn to the right. Okay? That's what I remember. So all of these things, I think many of them will be on the horizon. 3D printing of parts to be on the horizon, remote control, we already have some of that. Drones for surveillance, we already have some of that. Every one of our clients wants to talk about autonomous drilling, just like we're going to have self-driving cars, and like it's going to be ready by supper time Friday. I personally don't think so, but I'm an old curmudgeon too, so maybe the industry will surprise me. But I wanted to show you the 2 case studies to show that innovation does happen, and there are some things that we can be at least minor or even larger game changers in a shorter time frame than the 30 to 40 years that it took us to. We haven't perfected horizontal drilling and fracking yet, or even 3D, 4D kind of seismic, but we continue to work on it. There are some things that maybe we can generate value from quicker. So, leaving with a few thoughts. It is still early days in our industry to uncover opportunities for improvement. However, there's a temptation to drive a digital strategy just because there are data now available, or just because there's computing power now available, right? And we can apply massive computing power to doing things the same old way, and we just get more solutions, or maybe a little faster, which is good, but it may be not quite game-changing. I think there has to be a thought process, or thought, or a breakthrough that then applies that data, or applies that computing power to really change the cost curve for us. And maybe that'll change our cost curve over time. So when the opportunities are driven by a business need, by a business imperative, by shareholder value, by safety, by production, by capital efficiency, then the opportunity targeted towards those business needs have a bigger chance of success, and more importantly, a bigger chance to be deployed across the industry. Because you could do a really cool analytic study on something that doesn't matter and be right, but it'll never be deployed across the industry. It'll never take off like 3D took off, or logging while drilling takes off, and so forth. Our industry does need to experiment a little more. I mean, absolutely right. We're as risky as the things that we do are. We're very risk averse on trying new things, new tools from Schlumberger, new analytical techniques from the think tanks or consultancies and so forth. Generally speaking, these are low CapEx, low OpEx opportunities. They're generally speaking lower risk, but as Bob said, it's hard to get people to take up a pilot, even if you were going to pay for it for them. So you're not doing that on my well, or you're not doing that on my reservoir. I already understand my reservoir. I don't think a machine's going to understand my reservoir that I've worked on for 20 years. So that mindset has to change a little bit. And I think one of the risks is if some of these digital technologies do mature to the point that they can really change the way the industry operates, it changes workflows. It changes the way these organizations get work done. And the organizations have built around themselves centers of excellence or pockets of expertise in geophysics, in geology, in reservoir engineering, in well construction, in completion. Even if you go to things that might seem administrative to you guys, like land, the land guys are land experts. And you're not touching my land system, or you're not going to get my land data because you might do something wrong with it, right? And I don't want to let you do that. Plus, just culturally, it protects my area of expertise, which happens to be land, or happens to be reservoir engineering, or happens to be well construction. So those things, longer term, I think, are the bigger inhibitors to change than the actual technologies. Technology will find a way, like it did with fracking. It may take 4 years, it may take 10 years, it may take 30 years, but it will find a way if we have some innovative operators who are willing to deploy them. Questions?
All right, so we have good time here. We have about 40 minutes. So open up questions for all of our panelists. Go ahead. We have a mic there for people to if you can speak loudly, it's fine.
Don't get up, I can hear you.
We have a mic up there.
Since I'm standing here, David Knappman, as you tell, Institute I have a very self-serving question. Is the shale revolution just starting with oil and gas? The reason I'm asking that is that Jason Bordoff's assistant, he's chairing the final panel that I'm on, said, here's some questions to think about. And I figured we have a session where you guys are not only thinking about it, you're kind of living it. I know Bob's answer, but if I can say the panel has said, and I'll share with you, Bob spoke at CSIS meeting with Guy Foods or Frank Carrasco, and he did this wonderful parallel between where conventional Permian production was in the 1920s and where we are now. 5% recovery, all primary, and you guys are now talking about these other things, whether it be EO2 flood, the CO2 flood at EOR, some of the things that Bob's talked about with naphtha, and some other things in the fluids and whatever. But the general question, is it fair to say from 3 experts who were kind enough to share their expertise with us this morning, and thank you, great presentations, really enjoyed it. Is that a fair statement?
I'll go first. Yes, we are just starting. I think that I'm not even sure I would agree we're hitting found all the sweet spots, even in the United States. I think there are still sweet spots in formations that we barely drilled. It took 140 wells to really find a good, productive well in Niobrara before we really started developing Niobrara, for example. So I think there's lots of opportunities that still remain in the U.S., but I think there are also going to be technological innovation that has to go beyond that sweet spot to the next tier. But we've not even scratched the surface of the opportunities elsewhere around the world. I mean, there is shale pervasively everywhere. We did a study for the Energy Information Administration about 5 years ago, where we just, based on analogy and data that did exist, looked at the shale and tight oil potential in other areas. And it was the only areas where we had good data. It wasn't even areas where there was good data that could also have potential. And it's pervasive. I mean, we are just beginning both on the technology curve and certainly on the resource curve, in my opinion.
Generally, I would defer to 38 patents. I just think time-wise, if you thought of nothing else, is it realistic to think that over the course of 6 or 7 years when it's really been heavily commercialized. Not the 30 years that it took to research and to think about it, to try one, or to try vertical frac in the Barnett and so forth. But the point where many companies, service companies, academics, and operators are actually trying to optimize day in, day out while they maintain their development plans and their development programs. Is it reasonable to think that we figured it all out? Or, I mean, maybe some people are clever enough to have figured it all out, but I find that we innovate all the time and we find things we never dreamed of. And to be only a handful of years really into this revolution being at scale, I highly doubt that we figured everything out.
Well, Dave, you've already sort of answered your question for me. And so I'm sticking by that we have a large technology upside. I'd just like to say that I think to make that next step in technology, we're probably going to have to see considerably higher oil prices. For instance, the CO2 EOR, very interesting, obviously, but at present cost structure, not happening at $40 a barrel. I mean, we need too much new infrastructure. And plus sources of CO2 and capture is expensive. Yes, there's technical possibilities. The question is, but it's going to be a while before we need them because there is so much conventional oil, so much U.S. tight oil. So I'm not looking for anything in the next 10 years.
One more of a comment than a question. That I convinced Tom Olbrand, who I think all you guys know, a few years back to write a book on the shale revolution, because the two of us were quite confused about a lot of the mythology, that it took $140 prices to make it happen, that we found something new, that all these technologies around had somehow just happened or just got discovered. And what we came up with was the idea that geologists have changed the way they think about what their job is. The great geologist was the guy that was the best at figuring out where the oil stopped, and they didn't care where it started. Source rock was something that was the last two paragraphs of the geology. And the reason I bring that up is that is also part of the evolution of it, is creating the people that are going to be able to take advantage of these shale deposits, which as pointed out, and that was a lovely study. Bella Krushka is, in fact, one of my unreferences, along with Bob Skinner and now Bob Kleinberg, that I've learned just enough of the words to become truly dangerous about geology. So with that, I will be quiet.
All right, please. Go ahead. Yeah, go ahead.
Hi, Latika Gupta, Assistant Professor at Michigan Tech. So this story that I'm hearing is reminding me of the history of coal and how coal was actually the coal industry was actually pretty slow to adopt machines, and not that oil is in any way at that point. You know, coal was, the early phases of coal industry was known as the hand loading era, and they were pretty much loading by hand, as the name suggests. But you know, the way in which it's reminding me of that is that they were very resistant to using any kind of technology. They were resistant to using any kind of machines, and part of it was due to the low prices. And even when they started using machines, the machines came from outside of the industry, and the innovations came outside of the industry. So this is where my question is coming from. Do you know of any innovations, or do you know of other industries where innovators might be trying to create products that might be useful for the oil and gas industry?
Well, I'll start with, I mean, certainly on the EOR side, I think, you know, the pressure to figure out how to safely store CO2 has invented a lot of, or is developing a lot of monitoring technologies that have always been around, but they just haven't really been applied in this context. And so whether it's pressure monitoring or you know, crosswell seismic or vertical seismic profiling or other things that are just more cost effective than perhaps traditional 3D seismic, can be very expensive and hard to do in many places, is in fact beginning to find its way into the storage industry. And then, as I said, then application and storage is then finding its way back in EOR. Clearly, digital technology didn't start with the oil and gas industry. I mean, it started with everything else. And perhaps we're the last ones to really jump on the bandwagon. So I'm not sure, and I'm sure there are others, and I've actually sat down and talked about it, or you bought me a beer. I probably really haven't figured out some other ones, but I think you're right. I think we haven't thought about the cross-applicability nearly enough yet that we need to do.
I'll just throw in my little note. In the last session, I was at a talk where they talked about methane sensing using drones, and that looks like the best way to find methane leaks, which is a huge problem, an unspoken problem for our industry. And so that's one example. I'm not sure it's a kind of example, but just.
Thank you.
Scott, I think one of the difficulties in our industry is in the upstream side, we're fundamentally a B2B kind of industry, right? We are not a retail industry. We don't have 310 million possible customers that we touch every day on their iPhones. And so the innovation, the digital innovation is around banking and buying your insurance and ordering, new shoes and jackets on the internet. It's not really available to us. Maybe if you go all the way down to the retail gasoline and lubricant side, there's some opportunity there, which actually should be deployed, I suspect. Back office technologies that are being used in some other applications that are being experimented with, blockchain and so forth, you can imagine that becoming adopted for royalty payments and rentals and things of that nature over time. We'll probably be a little slow to adopt that too, Shree, but that's easier, one would think, to do in the back office. In the oil field and the upstream side, though, is if reservoir physics still applies, then kind of, as I say, typical data science and just general neural networks and so forth are going to struggle to optimize some of the assets that we are trying to optimize with the tools that Schlumberger builds and enhanced oil recovery, secondary recovery, tertiary recovery, all rely on physics, which is just a wrinkle, right? It makes it more complicated.
I think the other important point to make too is that we are dealing with data that exists at a very dispersed level, a mile below the surface of the Earth. And so you can do as much as you can with what you got, but you never know everything. Every time you drill a new well, you generate new data that may fundamentally change what you thought you knew before. And so I think you have to recognize that not only is it a machine learning at a point in time, but it's got to be a learning continuously as you continue to bring more data into the process, just on the data side. Clearly, that's been the case with operating in shale as well. I mean, it's a lot of trial by error, and try this, try this, oh, that worked. Let's take it over to the next basin. Didn't work there. You got to do something else. And so there's a lot of applicability, learning that you got to do in the setting that you're operating in. It isn't necessarily always transferable exactly the way it was the last time you applied.
Go ahead.
Thank you. Hi, Mark Finley with BP. Thanks to all the presenters and Shree for chairing the interesting panel. I had a question for Bob. I mean, you mentioned that one of the reasons why the industry is kind of slow on the uptake of innovation and the diffusion of it was the big upfront capital costs and the geologic risk and the project times. And I just found myself thinking, does shale change that? Because there's less geological risk in some sectors anyway. That this is not a $100 million offshore platform. It's you're drilling thousands of these wells, and so does that eventually take away some of that obstacle?
Well, Mark, that's a really interesting observation. It's a good question. I would say the inertia in the tight oil, shale gas domain tends to center around the fact that it's very much a factory drilling process. So in other words, you're actually drilling a lot of wells, which is good, and sort of, I think that's one reason why maybe this learning by doing has progressed reasonably fast, because you're drilling 15,000 tight oil and shale gas wells a year, so that's a lot of wells to be learning from. On the other hand, they are drilled in factory mode with complex and long supply chains. You're talking 10 million gallons of water per well. You're talking, it would be 10,000 tons of sand per well. So that tends to add some inertia to the system. So I'd say it could work either way. Yeah, I'm maybe, maybe not. It maybe depends on the operator.
Back here.
Ken Walsh from Leidos. One question about the shale is, which decade do you anticipate other countries starting to adopt these, and which countries do you think are going to be first?
I'll answer definitively. I don't know. The question is, which decade will shale technology begin to emerge in other countries? And my definitive answer is, I don't know.
You know, I've read the ARI report, which I consider the best thing out there. But I've also sort of looked at it in detail and then looked at our field experience in places like Poland and China, and it's been a little discouraging. I mean, there are certain things about North American geology that appear to be kind of special, and one is that gas is created at great depth. But what we find in our North American reservoirs is that it's been essentially a process of geological uplift, which has brought that gas to a depth where it's relatively cheap to access. And that's unusual. So there do seem to be some special things about North America that are particularly attractive. Now, if you take Vaca Muerta in Argentina, that is also a very good situation. So Argentina is exceptional in it. And if Vaca Muerta were in Texas, it would be exploited to the limit today. But there's not too many other examples of that, and I'm an open mind as to future exploration. Russia is probably a good place to look, but many places seem to be not so promising as one had thought.
And you have other resources in many cases that are still not very well along its depletion curve, and so there's not a need to go after yet either.
Yeah, that's particularly true of Russia. Right.
Well, one question, Bob, on that one is the availability of the service sector in the U.S. and how they work. Is that a factor as well?
Yes. We call Western Europe a frontier area where service costs are 3 times higher than in Texas. And of course the Europeans are pissed off. But that's the fact of the matter. Yes, our service infrastructure is unparalleled. It's not unparalleled. You find similar things in the Middle East and Russia. But other than that, you have to really build up your infrastructure.
Peter?
Harvey Russ, just want to follow up on this question. I've had geologists in Australia tell me that they claim that the big difference between North America and Australia is that here fundamental geological forces tend to pull rocks apart, whereas in Australia they tend to be compressive. So they're saying one of the problems they have is when you frack there, there's a tendency for the frack to be closed by these pressures. You know? The argument is like Australia pushing up against Asia, the way the plate tectonics works, they claim.
Yeah, I'm honestly not too familiar with Australia, but that's certainly the case in China.
Yeah. So that is something unique about North America, they say, that it's really made extraction much more productive.
Go ahead.
I want to follow up on partly what Mark asked. I'm John Valentine, Brandeis University. The new conventional wisdom is moving towards faster energy transition. Looking at the BP scenario, whatever. But I guess the question you're sitting here is, if you can implement the innovations, it may make sense that implement the innovations, meet some of the climate change constraints, and still be at an 80% fossil fuel world rather than the 60% that BP has in its faster transition, and have a lower cost of energy.
Yeah.
Is that a reasonable takeaway to looking at this innovation sort of perspective?
That's a really good question that I wrestle with a lot. Is are we just facilitating a transition, or I mean, I think it was, I forget, one of the emirs of Saudi Arabia or somebody once said the Stone Age didn't end because we ran out of stones. The oil and gas age is not going to end because we run out of oil and gas. It's going to become, something will become better, cheaper, more efficient, or more climate oriented. Can these technologies maybe delay the need to go to 100% renewable? I think so, especially when you think of what needs to be done from investment, from development, from technology, from infrastructure to get to these renewable scenarios. To the extent that you can take advantage of existing infrastructure, expertise, technology, maybe if we do it right, it can help get us there. Certainly cheaper, if not quicker.
I actually have two more. So as an academic, what tactics can you see that would be most effective in getting operators to opt into experiments per se? Whether it's like water related or leasing related, something along those lines. Secondly, in terms of like replicability abroad, how do international things like mineral rights and other infrastructure, regulatory or experience type hurdles create issues or prevent development abroad?
I might comment on the first one. You know, the history of fracking, we've gone through a little bit today. We talked about Mr. Mitchell and so forth. Obviously, companies like Chesapeake were very, very aggressive in the early days, up in the frontiers of the Marcellus and so forth. I actually have a concern. I don't stay up at night worrying about it, but I have a concern that when the big boys come in and take over the unconventional, they put their factory models together and so forth, that the risk-taking and innovation gets stymied a little bit. The friction that Bob was talking about happens, right? Whereas if you were gunslinging, you know, Sand Ridge 6, 7, 8 years ago, you just did it, right? You had a guy on site, you said, we're going to do this. Company man says, let's do this. They called in Schlumberger and they did it. And it worked, or it didn't, and they figured it out over time, right? But it was a short period of time because they just did it. The processes were more streamlined, they just had the cowboy mentality. And I do worry a little bit that as these basins have become so prolific and it's the place to be, that when the big boys come in, some of that innovation gets stifled or stymied or just never even bubbles up. Whereas other guys would say, hey, if it looks like this, shoot it, right?
I'll add to that, and I think this is, I do a lot of work in government R&D, in government-funded R&D, and all government R&D projects, to get awarded, you need to have a little bit of industry cost share to make it work. And so what you do is go to these guys and say, I'll bring the technology, I'll bring the reservoir models, I'll bring the geologist, just give me a well to try it out on. And let's see what happens. And you can give me a bad well, I don't really care. Let's just get a well, let's try it out. And almost no risk to you, and all upside. But you really have to have without a government role, that's kind of hard to do. You got to have somebody who's willing to take more risk than those oil and gas operators are willing to do with their own money to make it happen. And that's work. To answer your second part of the question, yes, those kinds of things hinder development everywhere in all kinds of ways, and they still do, even in the United States. And you got to work through those to really make it happen.
Well, I'll address the mineral rights question because I think it's widely misunderstood exactly what the effects are. If you want to design a system that would prevent the exploitation of oil and gas, you choose the American mineral rights system. Because, I mean, Aubrey McClendon worked his ass off to assemble 1 square mile lots where he could drill for shale gas. I mean, it is an immense overhead in the industry to have these landmen going to county courthouses to figure out who owns the damn mineral rights on each square mile. So would that be the system that you would design to encourage? No. But on the other hand, if you look at a country like Australia, where the mineral rights are crown property, and therefore there's only one owner to deal with. Only one owner. Wow, that's got to be simpler. It is, except because it is a public resource, it has, in Australia and other countries, become a political football. So what happens is that every time you want to develop your square mile in Australia, you're going to be dealing with protesters, and that's doubly true in the UK. Where the same thing applies. So I'd say the fact that we have this privately owned subsurface where you're not going to get abandoned demonstrators to protest about somebody selling off their 3 acres, right? Not happening, and would not be tolerated, because hey, he's a small guy, why beat up on him? I'll tell you, it is an interesting situation that is worthy of some more serious study than I've given it.
Just a footnote on that though.
Yeah.
There's an awful lot of mining in Australia.
Yeah.
Right? But it's all in the remote areas where, deserts, etc., where you're not gonna get the protest.
And it's not so controversial as fracking and so on, blah, blah, blah.
Well,
So,
it's a long way away from everywhere.
exactly, so if you've got some crown land a long way away from people, then probably that's the best situation.
I think on that note, we should end this session. We have a lunch coming up in Adams and Madison Room. Please join me in thanking all the distinguished.